Let's go full screen there. All right, let me close this bad boy up here. And let's see, we're back. This is going to be analyzing categorical variables. So you remember yesterday, real quick. Well, not really yesterday. It's actually about 5 minutes ago, but hey, it's all good. I'm trying to get caught up for you guys. So just remember categorical variable. We have two types. We have categorical variable, which is what we're going to talk about right here. Categorical. And, it's got nouns with it like male, female, those types of thing. That's what we're dealing with when we're dealing with categorical. Or we have what we consider quantitative. So we have quantitative. So we have quantitative ideas, and those are just numbers and stuff. So when you display categorical data and quantitative data, they're displayed differently. So most of the time, we take categorical data and we display it in a two-way table. And you guys have seen two-way tables before. They just they summarize association between two categorical variables. And that's usually with proportions. So let's just make a two-way table. Guess what? It's got it's like a Punnett square, really. It's two of them here. And for some weird reason, guys, and those of you that have had my classes before, I literally cannot draw a straight line down I can do it on a piece of paper, but I cannot do it here. So let's just say we have male, female, A's and B's. So and these are our grades. So let's just say GPA. We'll just make it really simple. GPA, that's a GPA, not a GRA. And then male and female, so this would be gender, right? A lot of things are this way when it comes to two-way tables. And then let's just say that males, there's 5, they got A's, and 10, they got B's. And females, there's 12 and 2. Props to the females. Look how much better they are. All right, so here we go. So then there's 15 total here. There's 14 total there. There's 17 total this way and 12 this way for a grand total of 29. I always get weird odd numbers when I make stuff up. Okay, so that is a two-way table. Notice two ways. There's this way and this way, so it's two ways. So now we have our rows and we have our columns. So now we start working with things and we start saying, okay, what is the joint relative frequency? Okay, first of all, relative means percent, which comes from a fraction, right? So we need to come up with a fraction. And so this new word right here is a new piece. And it's basically where, as I say down here, it's where a row and a column come together, like two bones. So if we look at this, we go over to here and we go to here, the joint relative frequency of males that get B's is 10 out of 29. Okay? That's the joint relative frequency. Males that get B's. All right. So that's the idea of joint relative frequency. And then we can turn that into a percentage if we wanted to. In a calculator, you go 10 divided by 29, which is probably going to be about 34% in there somewhere. Pretty close, okay? So then there's conditional relative frequency. So, oops, I skipped one. I can't believe it. I saw it right now. Let me change colors. You guys are probably like, you skipped marginal frequency. What are you doing? I'm confused. So marginal frequency. So, yeah, that's the only other problem is like you can't scream at the screen and tell me to go back. But if you were just screaming at the screen and said, he didn't go over relative frequency, marginal. Okay, I did now. All right, so margins. Margins are on the outside. So you get your marginal relative frequency from here and from here. And it's usually a different type of answer. And this is getting a little crowded. So next time I'll have to do it differently. So margin of relative frequency would be the number of students that got A's. And I know I'm a little bit crowded here. So the number of students that got A's. How many got A's? 17 out of 29. So that would be 17 divided by 29. And the reason it's called marginal, it's because it's outside in the margins, just like a piece of paper. So you go outside the margins. Joint relative frequency is where they meet. So the leg bone meets the hip bone kind of thing right there. It's where your knee or your thigh bone connects to your shin bone, and you can kick somebody like whack, you can whack them one. All right. So that's what they mean by joint relative frequency. Now, conditional relative frequency means we're going to say the number of females given they received A's. So we're setting a condition. We want the number of females considering they got A's. So then we're looking at the A column here. Man, that's ugly. I got stuff all over the place. Some of you that are let me have trouble visualizing this. Let me rewrite that real quick so you guys don't like freak out. Oh, that was close to straight down the page. Getting better. So we got 5, we got 10, we got 12, we got 2, we got A, we got B, we got male, and we got female. Okay, so what we want is a number of females given that they got A's, right? So we don't care about B's. So since we don't care about B's, we just get rid of them. So now we want the number of females that got given that they got A's, and we want it as a relative frequency. So that means it's 12 out of the column total, which is 17. And so then that would be a percentage, which again is about 67% ish in there somewhere. That's what I'm thinking. 67%. So that's the idea between relative. So conditional frequency. You always condition on the afterthought, like given that you'll be able to see it in the statements, and there's so many examples of it. So we're just going to make sure that we know what they're asking us, and we'll do some examples, and we'll get stuck on some things, and we won't get stuck on some things. So just remember a condition or a conditional distribution, which is kind of the idea. So the conditional distribution is I changed it into male, female, and then A, 5, and 12. So this is how I represent the variables and the values that they came up with. So that's our conditional piece. Okay. So that's kind of what you may have a little more questions in class on that one. So that's fine. But just think about how it works with explanatory and response variables. And there's a good two-way table on page 16 that you guys can look at. All right. So a segmented bar graph. Now, these are really, really good to use. So we got a bar graph before. So let's just take this graph that I created, which is super irritating. So let's just go back to the two-way table, Monday through Friday. I'm already messed up, guys. And we got A's and we got B's and we got male and female, and I put 5 and 12 here. What else did I use? I don't even remember. Oh yeah, the girls were much better than the boys on this one. And we got 10 and we got 2, right? So this is my two-way table. So let's break it up a little differently. Remember, we like percentages, so we're going to create. Oh, that was pretty straight. Some of you just cheered for me. I know it. So we got Monday. Do it again. This is not Monday. This is male. And this is female. Okay. And then we're going to go up all the way to 100%. So segmented bar graphs deal with percentages. And then I'm going to look at this and go, okay, this is out of 15, right? And this is out of 14. So if I'm looking at males, I know that 5 out of 15 get A's. So that's 33%. So I'm going to go up to 33%, which is right about there. And that's a horrible graph. So if you have trouble drawing, just look at my stuff. It'll make you feel better. And then we're going to go B's. So this had five people, but it's 33%. And if we had this here, it's 10 people or 67%. And I'm going to do just a different color. You can do, oh, no, I'm not. Apparently, I'm not very good at that. There we go. I'm going to do a different color, and we're going to go all the way to 100% with that because there's only 2 data points. And we're going to write 10. So this one has 67% in it, right? And this one has 33% in it. So if I go to the females, I do 12 divided by 14, and I have no clue what that is. So let me get my handy dandy calculator here. Sorry for the delay. I made a really bad number. I got to stop doing that. That one's 86%. So for the A's, and I'll do this one in a different color here. Let's do white would not be good. Let's do this orange color. I said 86%. So we're going to go all the way up to 86%. All right. And we're going to come back down. We're going to draw a bar graph. Remember, if you're drawing this, you're drawing better than I am because I'm horrible at this. So we got 86%. And then the last little bit here is, let's just do red again. No, I don't want red. We already have red. Let's do purple. The last little bit here is going to be 2 of them, which is only 14%. So these are segmented bar graphs here. Segmented bar graphs use 100%, and they just turn the fraction of whatever condition we're dealing with here into a percentage, and then it makes a visual piece. So we already knew, based on the data I gave you, that the females had a much higher percentage of A's, but we also now visually can see it on a 100% bar chart. So it makes it as a whole. So that makes things a little bit easier. So just remember that we've just got to decide if we're dealing with marginal, conditional, or relative joint frequency, whatever frequency they're dealing with it as. So if we're looking at, let's just do this one here. What proportion of the sample use iPhones? We're looking at a marginal relative frequency. iPhones, go over to iPhones, 467. So it's 467. 67 out of 2024. And you could turn that into a percentage if you needed to. What proportion of the sample use an iPhone and are 55 plus? So we've got this and word, which really makes it a joint. So we're going to go to 55 plus and iPhones. So let's change colors on you on that one. So we're going to go to 55 plus and iPhones, which is right here. It's 127. There's a horrible circle. So it's 127. Oops. Control Z. 127 out of 2024. And you can turn that into a percent by dividing it in your calculator. So what proportion of 55-year-old people in the sample use an iPhone? We want 55 first. So we want this column. Okay. We want this column because it's telling us what proportion of 55-year-old people. So we could care less about 18 to 36 or 35 to 54. And so our fraction is going to be the iPhone users, 127 out of 870. That's our conditional. Now we can flip the condition, and let's go ahead and pick a different color here. We can flip the condition. It says what proportion of iPhone users. Now we're in iPhone land. Let me erase some of this stuff so we don't get. So now we're in iPhone land, right? Who cares about that? And let's go back to this. We are in iPhone land here. We'll go, yeah. Oh, no, I'm not. I'm with that one right there. We're in iPhone land. So we really only care about this right here because it says what proportion of iPhone users are 55 plus. Well, let's just use yellow now. 55 plus. So now we're here. We're still where we need to be, but it's going to be 127. I promise I'm going to get better at this, guys. 127 out of not 2024, not 870, but it's going to be out of 467, which is our total iPhone users. So that's the proportion for that one. So that's the kind of the idea. So what does it mean for two variables to have an association? That is my fax machine going off, which I just turned it off. So what does it mean for two variables to have an association? So let's go back up here. The question I have is, can you visually see or say, oh, if I know they're a female, I know they have a better chance, or it's more common for them to get A's. If you look at this data, you know that. If you look at this and they walk into class and they're a female, let's say this was the average of the average grade for the last 20 years in, I don't know, let's say Mr. Lamb's weight training class. And so when you look at that, you would say, oh, well, females do better in his class than here. They work harder or whatever it is, so that's what they mean by association. When knowing one variable predicts another variable, that's the key piece, when it predicts the other variable. So that's how you know they have an association. And how can you see an association? Well, I just showed you with segmented bar charts. Those are the best ways to see associations. Segmented bar charts, changing them to relative frequency and changing it into that. All right. So explain what it means if there's no association. So let's just take the idea of the age and the cell phone. We know we can look at this and go like, look, 55 plus. This is from a while ago. It's not 2024. I'm sorry. These are older ones. The book's older. We're getting new books here soon. So some of the data is old, but you guys can see what's going on. The idea here is that you can see that the older you get, the more you're choosing other phones, right? That's the idea. You can see how that's working out there. And you can visually see that piece. So if it didn't happen that way, these numbers would be even. All of these numbers right here, oops, there it is. All of these numbers inside of here would be even. So your percentages would be the same. You'd have the same basic percentages for their choices. So there would be no ability to say, oh yeah, I'm older, so I need a less smart phone, which is what it's saying. So let's finish up here. And will be video number 2, and we're rolling. So here it is, guys. So this is the idea behind statistics. So they always pose a question here, like, what's the association between age and cell phone type? And they always have you justify it. So the question is how do we organize statistical problems? So it's not so heavy now, but it will be. You need to state, you need a plan, you need a do, and you need a conclude or a conclusion. State, plan, do, conclude. Or another way it is statistics, problems, demand, consistency. So we're always doing state, plan, do, conclude. So you state the question or the hypotheses or whatever we're dealing with. Is there association between age group and cell type? What's the plan? Since we suspect age is the determining preference, we will actually compare our different age categories. So remember, when we're dealing with association, we like to use segmented bar charts using percentages. So I've already done the math for you guys. If you're 18 and 34 and choose an iPhone, it's 32%, Android 41%, other 26%, 35 to 40. So you can kind of see this. So if we drew, oh, that is just horrible. I'm going to try something here real quick. Bear with me, guys, because that's just wrong. Let's try this one. So if I go like this, Oh, I think I just found a shortcut. And I go like this. Oh my goodness. No more drawn for me. I know they're different sizes. I know those people that are totally OCD, you're like going, oh my gosh, don't do that. They're different sizes. I can't see it. All right, I'll try it again. Here we go. Let's try one more time. Let's go one more right there. All right, I'll try to make them as close as I can, guys. All right, and I still sucked at it. All right, that's okay. All right, so then I'm going to go back to my drawing here. Look at this. I'm getting better at this all the time. So then I'm going to color code everything. So iPhones are going to be yellow, and then Androids are going to be blue, and then old people phones or other are going to be purple. So if I do this, and I'm going to go back to yellow. So 18 to 34, I'll just do it here. Don't forget to label everything. So that'd be 18 to 34. I'm running out of room, so it's really hard. This would be the 35 to 54, and this is the 55 plus. So I'm going to go back to yellow here. If I look at this and I'm going to go iPhones, 32%. So this is about 50. So 32% is right about there. And then 41%. So a little bit more for, oops, nope, I don't want to do that. That's wrong. Z, it's a little bit less, 26%. Here we go. And then 14%, they're way down here. Okay, and then now we're going to this one here. We're going to Android. Android's 41%, so 41, so we're all the way up here. It's going to be a little bit bigger than that. And then 30%, so 30, 70, so it's going to be just a little bit bigger than that. And then 12%, so these people are just like laggers. So 12%, all right? And then our last one is purple, which will be the remaining area here. And let's look at it. So if we look at this, out of 100%, the purple grows as we get older. So based on the data, there's a high association for 55 plus age groups to have a non-smartphone. This is from a while ago. They had flip phones and all those different things. So they like to choose non-smartphones when compared to the other two age groups. So older age groups are more likely to choose non-smartphones. That's an association. Their age is associated with what chart they use. Okay? All right. So then I throw stuff in there like this. This is the example we're going to go over in class. That's our class example before we start our work. So hopefully you've done the work and all these notes and different things. And let me know. I mean, I take critiques pretty good. So if this totally sucks, but these are all pre-printed and they're yours and ready to go. So that is yours, and we'll try another one.